Okay, hi, Kiran here. Today I'm going to be doing a little tutorial on using Org-roam to do sort of literature review and take notes on papers. So without further ado, let's get started. Today I'm going to be taking you through sort of me doing literature review for a particular paper that I've been looking at. In particular, I'm sort of doing, let's see, how do I get there? Okay, here we go. So I'm at the moment doing a literature review on specification synthesis techniques. This is a particular sort of idea from programming languages. Don't worry about it. It's not important. The point is that I am, at this point, have been given sort of a number of papers to start my literature review from one of my co-authors. I've been reading through them, but I have one remaining paper, which is this one, neural acceptance-driven specification mining. Nice thing that you might be able to see on screen is that is this nifty feature of Org-roam, obviously taken directly from Obsidian, if you're familiar with that. Shows you a little graph view of your research, of your sort of org database. It's kind of a gimmick, but actually when I'm doing literature review, pro tip for PhD students, this is a game changer. It makes it so much more fun to read through papers because you're like adding these nodes and it gives you a very real sense of progress as you're doing that. Anyway, today our task is to read through this paper, NADA, Neural Acceptance Driven Approximate Specification Mining. Obviously, for the purposes of this video, I'm not going to be doing like a proper read through. If I were actually doing this in reality, which I'm going to do afterwards, obviously, I would actually read through this paper in detail. But for now, we're just going to read through the abstract, and I'll give you an idea of like how I do note taking using Org-roam and like papers and Zotero and all that integration stuff. So here's this paper, NADA, Neural Acceptance-Driven Approximate Specification Mining. My co-author apparently thought that this was a very relevant paper that we should include in our literature review. Okay, so let's just quickly read the abstract here. It is hard to mine high-quality finite state automata from only desired software behaviors, i.e. positive examples because of a search space explosion. Okay, so it's hard to mine high-quality finite state automata, gotcha, from desired software behaviors, gotcha. To tackle the overgeneralization problem, we suggest modeling the problem as searching for approximate FSAs from positive and negative examples within noise. Where the noise originates from synthetic negative examples, users reject overgeneralized results. To obtain effective search bias in the exploding search space, we bridge FSA acceptance neural network inference. Key contribution is to design a neural network whose parameter assignment corresponds to an FSA, and neural inference process named after neural acceptance is able to simulate FSA acceptance. Okay, cool. Capture some stuff. ... Accepting positive, rejecting synthetic negative examples. It's based on a relaxation of the discrete search space of FSAs and a gradient-based search algorithm. Okay, gotcha. So, I don't know how relevant this is for you, but it doesn't really matter if you understand it at all. I'll just walk you through me taking notes for this particular paper. So, at a high level, this paper seems to be something about specification synthesis. It seems to be sort of doing specification synthesis, so paper about specification synthesis. And now what I'm going to do here is I'm going to add a link to my previous concept of specification synthesis, and as you can see on the Org-roam little UI, you can see that it's kind of updated and added a link. That's cool. I get a little dopamine hit. Yes, we're doing research. Paper about specification synthesis that focuses on specifications where the behavior of a program is described using a finite state machine. And I think I do have FSM, finite state machine. And the key innovation in this paper is to define a mapping between FSMs and neural networks. Neural network, I guess, cool. Between the FSMs and neural networks, such that we can exploit stochastic gradient descent CNI, stochastic gradient descent, to learn an FSM. Okay, so with that, I've kind of finished my reading of the paper. Obviously, again, for illustration, in practice, I would obviously be reading the entire thing. But yeah, we have kind of like a summary. But by the end of this, I have like a long list of description of like my notes while reading through the paper with a bunch of links, and you'll see the graph would have like really, blossomed out. So all good. With that, I've kind of finished reading the paper. The other thing, and hopefully that's given you an idea of like how you can read through papers, and you can just do this side by side. It's on a little MacBook screen. Brilliant. You can just, oh yeah, great. Brilliant, love it. Another thing that I want to show you is how this actually integrates with Zotero and better BibTeX. Okay, I don't know what I did that. Okay, okay, let me just close this. All right, cool. So when I started off this paper, I jumped into this link, NADA neural acceptance-driven sort of symbolic mining, and that kind of zoomed me in there. We can, I realize it's kind of like a little bit small. Let's just zoom in a little bit. Cool. Nice. All right. Anyway, but with this kind of like, the title of this paper was already there, right? And you might be thinking, Kiran, did you write that down yourself? No, actually, this is actually entirely synced with my BibTeX, and this works beautifully. And I just want to show you how that works. And let's say we're reading through this and we see that, okay, reading through the introduction here, it says, API misuse has been recognized as a major cause of bugs and vulnerabilities, right? This is a nice little snippet. If I ever am writing an introduction and I want to talk about like API misuse causing bugs, something, seems like a good paper. So I'm just curious, what is this paper? Let's have a look. This is by Nadi et al. And it's from Jumping Through Hoops. Why do Java developers struggle with cryptographic APIs? Okay, interesting. Let's search Google for that. Okay, why did Java developers struggle? Great. Brilliant. All right. So this is a paper, Jumping Through Hoops. Quick scan of the thing, of the abstract. Let's see, what does it say? While cryptographic algorithms have become increasingly advanced, many data breaches occur. Okay, cool. So it seems to be like a source for the quote that order of API calls is an important thing that can cause bugs. Sounds good. Now, I'd like to sort of put that into my database so that like if at some point I'm writing a paper about, I don't know, API ordering and I want to quote, hey, this is an important problem, I'll have this paper on hand. So what I'm going to do is I have Zotero integrated with my entire setup here. Sorry, it just ran like one of my syncs. I sync my to-dos with my to-do list. It's cool. Anyway, I'm going to run Zotero. And Zotero extension has just now saved this paper to my database. And now, let's say I want to say something about like API, CNF API. Okay. Do I have an application programming interface? Okay, so here's what I like to do. Application programming interface. Like fancy term for a library, a sequence, collection of operations and methods that describe the interface with which a user can access the library. Okay, sounds good. So we just kind of define that. But here I might want to say like, API call sequences can be a common source bugs, right? Oh, before we do that, one like small thing that I want to say is here I've called this node application programming interface. Obviously, very rarely do you actually say that. This is a pretty verbose term, so typically people use APIs, right? So you can add aliases, roam alias, and I'm just going to call this API. So now if I'm ever looking up API, it's actually going to, no, I didn't do that yet. Okay, if I'm ever looking up API, it's going to show up in my list. So it's pretty useful. API call sequences can be called. Okay, so now I'm going to insert a new node. Fact. I don't know. I like to add like explanation of why this node is here. Okay, and then now, often the sequence of API calls can be done incorrectly and cause bugs in practical software, right? And here, when I jump to this node, I just want to add API as a link. And sometimes I need to like update the DB before it'll like appropriately set up the node. But here you go. You can see it's kind of set up properly. Cool. But this fact is kind of without without source. Obviously in a paper you can just write that without like putting a citation. Where can we cite this? Well, we can cite this paper right here. So let's cite it. Now remember, I've already added it to Zotero. So now if I do CNB, it's going to actually load everything in my bibtex. So I have actually set it up so that I'm using better bibtex with Zotero. So whenever I add a reference to my Zotero database, it automatically exports and like overwrites my bibtex which is then read by my Emacs. So now if I look for Nadi jumping hoops, wow, yep, that's exactly this paper, and it's exactly the bibtex key by which I would cite it in a paper. And so I can just say this paper investigates how easy cryptographic APIs are to use. And now I might need to sync the DB quickly, but if I jump here, empirically proven in the paper. Cool. And with that, I have this new node. It's just been added to my database. Brilliant. And if I were so inclined, I could go back to like the paper that I made on Nada right here, and I could say like, cites CNI jumping through hoops as in evidence that API call sequences and FSMs are a useful way of specifying libraries. Okay, and with that, we've kind of added this entire node to our database, and it looks pretty darn cool, as you can see. Okay, cool. So hopefully that's kind of given you an idea of like how I do this literature review. If we actually jump back to my original specification synthesis, you can see that I've kind of cut it down for the purposes of this video, but actually I've been doing a lot of reading, and a lot of these nodes, I've been adding links, I've been connecting between them. When they cite each other, I kind of like mention that, and this kind of builds up this huge graph. It's really fun to watch just in the background while you're like reading papers. Oh, add a new node. Oh, add a new node. Just, blossoming out. And it's just game changer for reading papers, because it's just like every paper is a joy to read, because you're just like adding to your database. Yeah. Anyway, right, I should probably show you how I set this up. Let me just quickly go to this, Roam, cool. So this is how I set up my Org-roam. Broadly speaking, let's see, I have this directory where all my Org-roam files are stored, and then I just used Org-roam bibtex, and that pretty much just handles, I needed to specify, I think, where my references are. Org-roam bibtex requires like you specify a .bib file, and then once you've set that up, it'll like whenever it changes, it'll auto reload. But the way this works is if you install the better bibtex plugin, this is my Zotero. Every time I sort of like use the Firefox extension, it adds to this like database of all the papers that I've ever read. And then if I go to better bibtex, I can I think it's in preferences, maybe. You can see that Yeah, I think it's better. Yeah. Essentially, like, okay, this is how it, like, there's some basic configuration, but the key thing that I've said is once you export it, like, I think, like, yeah, export, here we go. There's an option to sort of, like, automatically export, I think. Automatic export on change. So whenever your Zotero database changes, it dumps it to the file. And here I'm writing to org research references.bib. And so whenever I add a new paper through Firefox, writes to this file, Emacs picks it up, updates, and suddenly I can just automatically cite it. And it just works. It's amazing. It's so good. It's such a game changer for research. Anyway, I guess that's all I had to talk about. Hopefully it was helpful. Hopefully it might help you with your research. And if you have any questions, feel free to write in the comments. All right, well, that's all. Peace out. Bye.